All right, so if we're going to integrate with our trig identities, the double angle formulas are crucial, okay? Because if we've just got a single term there, like cos squared, we can't, if we substitute u in for cos, we differentiate, means there's a sine expression, and if there's no sine expression there, well, we're a bit stuck. So instead, if we think about our expressions for cos squared, so rearranging, okay, so from in here, we can see that cos squared x is equal to 1 plus cos 2x there, and sine squared x is equal to 1 minus cos 2x. So they're really two really important substitutions, because we can integrate both those terms. So obviously cos squared 4x, twice the angle. So if I bring the half out the front, I can write that as 1 plus cos 8x dx. And then if I integrate that, I get a half of x plus 1 on 8 sine 8x plus some constant c, yeah? Sine squared 4s similar. I've got a half out the front, and I can write that as 1 minus cos 2x. You see straight away the importance of knowing your double angles and whatnot. A half out the front, integrate antiderivative cos, so it's minus 1/2 sine 2x plus some constant. I've just noticed the 4x, boys, isn't it? So that should be an 8. That's an 8 there. That's an 8 there. All right, so be careless. So read carefully. All right, when we've got an odd ones are nice. If we've got our function raised to an odd power, just from the hint there, you can write it as sine x times sine squared, and then you can put sine squared in terms of 1 minus cos squared, or cos squared in terms of 1 minus sine squared. So just very briefly, if we continue on with this one, I can write that as sine squared, which is 1 minus cos squared x times sine x dx. Now we've got u equal to cos x, and du, derivative of cos is minus sine x dx. So let's put that a minus there, plus there, and dx. So now this integral can be written as 1 minus u squared, negative out the front, du, minus u plus u to the 3 on 3, plus some constant, and u was equal to cos x, so we'll substitute all that stuff back in. Alright, so let's have a look at b. So same sort of thing, I can write that as cos x times 1 minus sine squared x, antiderivative 0 to pi on 2 dx, yeah? Simply because cos squared x is equal to 1 minus sine squared x. So again, if we put u equal to sine x, derivative of sine is cos, so du dx is equal to cos x, so du will equal cos x dx. If x is equal to 0, u will equal sine of 0, which is 0. If x is equal to pi on 2, u is equal to sine of pi on 2, which is 1. So my integral becomes the integral between 0 and 1, cos x dx, 1 minus u squared du, u minus u to the 3 on 3, evaluated between 1 and 0, which equals 1 minus 1/3, which is 2/3. Forgot to push record, lads. So we'll talk through this one. So when any of the trig functions are raised to an odd power, it's really quite a nice process. It's quite a simple process. We sort of make use of the fact that sine squared plus cos squared is equal to 1. So here you've got sine cubed x is the same as sine x times sine squared x, which is the same as 1 minus cos squared. So now all of a sudden I've got 1 minus cos squared, and a little sine x dx, sine being the derivative of cos, so we can just do our substitutions, expand, evaluate and group terms. So you end up with a nice little integral in terms of u, and then substitute your cos term back in. I guess the second example is similar in the sense that the only thing that's different is that the cos expression is raised to an odd power instead of the sine. So with that in mind, we approach it in exactly the same way. Oh, that's right, yeah. Try to read my writing. Cos squared times cos is the cos cubed. Cos squared can be written as 1 minus sine squared. So now I've got a sort of function in sine squared with the substitution u equal to sine, its derivative present in terms of cos. So very similar process, boys. So I think I really do like the odd powers of trig functions are really quite nice to integrate. If we continue that on now, if they're both odd, well, it's 6 to 1/2 dozen, isn't it? It doesn't matter which one you pick. Here I chose to break the cos function into 1 minus cos squared, which is sine squared. So I break the sine cubed down into sine x times sine squared, and then we just repeat the process. So really, I guess the key is to remember that it's this this little step here that we've just got to be a bit careful of. U is equal to cos, even though we're integrating, we're finding the derivative of cos, which in this case is minus sine, hence the negative sign out the front. All right. So negative sign, multiply it through. Just be careful of those little things like that. All right. All right, both even is just a little bit messier in the sense that we have to use the sine squared form of our double angle. So what is sine squared equal to? That's equal to 1/2 minus cos 2x. Cos squared x is equal to 1/2 1 plus cos 2x. And in short, if you've got higher powers that are even, if they're both even, obviously if I've got sine x to the power of 4, I'm going to have to raise this whole term to the power of 2. Okay, and then you'll end up with another squared expression. Yeah, so if we use the double angle formula that we've got there on the right, ignore the little squared, of course, what are we going to have? I'm going to have the integral. I'll take the half out the front for sine squared. 1 minus cos 2x. And then I'll bring the half out the front for the cos squared. 1 plus cos 2x dx. That gives me a difference of squares. So I get 1/4 of 1 minus cos squared 2x. So now I can put dx, that's 1/4 of 1 minus, well, what's cos squared equal to? Cos squared is, that's cos squared 2x, so that's 1/2 of cos squared 2x, which will be 1 plus cos 4x. So just be careful here. So what have I got? I've got a quarter. In fact, I might multiply that quarter through just so we can just keep track. So I've got 1/4 minus 1/8 of 1 plus cos 4x dx. Yeah, so now if I integrate that, x on 4, 1/8 times 1 is x on, what's that going to be? Minus 1/8 of cos 4x, so we'll bring the 1 on k, so we're going to have minus 1 on 32 sine 4x, antiderivative of cos is positive, so that's fine, plus some constant. So we'll get 2 on 8, so we get x on 8 minus 1 on 32 sine 4x.